Okay, good evening, Lamai. So today we are going to revise, we are going to do a revision on the questions related to limits, right? Okay, let's start. So I sent you a video to revise limits, the theory parts and also some structures that you can get questions, right? Okay, so today we are going to do some questions based on that, but still I will just recall what you have learned soon, like the question patterns that you have learned, right? Okay, so number one, right? Number one, what is number one? We can get questions to remove factors, right? When we can have common factors, and then we can remove the common factors and remove the undefined conditions, right? Then we can solve like that. So for example, basically like this, limits of x minus 2, x squared minus 2 squared over x minus 2 when x tends to 2. This kind of a one, right? You just substitute 2 instead. You just substitute 2 instead and say, instead of x, and say, we can't go for a direct substitution. If you go for a direct substitution, you will get 0 over 0. Clear? Undefined conditions. So what we have to do in this kind of questions, we can break into factors, and if you have common things, we can cancel out and then we can proceed, right? See, now this numerator we can write as x minus 2 into x plus 2. We can factorize it as x minus 2 into x plus 2 over x minus 2. Okay, now we can cancel out x minus 2. We can divide both denominator and numerator by x minus 2. So it is just limits of x plus 2 when x tends to 2. So simply, what is it? When you substitute, you can substitute 2 here, and then you're getting 2 plus 2, 4 as the answer. So we can write the answer as 4. Clear? So that means when x get closer to 2, x plus 2 get closer to 4. That's the idea, right? Solving limits means that to which value does the function approaches? To which value does the function approaches when x approaches some value, some given value. Clear? That's what we find as finding limits. Okay, so here we get this. That is the pattern, the type number 1. Okay, then number 2, we can have terms with square root, right? Fractions with square roots. So when you have such kind of questions, what we can do? Yes, we can divide both denominator and numerator by the line that you have. We can multiply both denominator and numerator by the conjugate of the line that you have the square root. Square root එක තියෙන line එක දෙනවා. එයාගේ conjugate එකෙන් both denominator and numerator we have to multiply. Okay, so that is the way. I think I sent you an example from that also, right? Right. We will do one example from the tut, right? Limits of square root of x plus 5 minus root 7 over x minus 2 when x tends to 2. Now you assume that you get this kind of a question. You try to substitute directly. Now when x get closer to 2, what happens? When x get closer to 2, what is the answer from this? Right. To which value does this answer approaches? That's what we find. So you can just direct substitute and see first. Substitute directly. 2 plus 5, 7. Root 7 minus root 7, numerator 0. Denominator also, when you substitute 2, that will be 0. So we can't do this because we are getting undefined condition 0 over 0. Clear? Right. So what I have to do, I will multiply both denominator and numerator by conjugate of the line that you have the square root. Clear? Right. So multiply by root x plus 5. It is minus root 7. So plus root 7. Conjugate means if it is minus, you have to change the sign to plus. If it is plus, you have to change the sign to minus. Root x plus 5 plus root 7. Likewise. Clear? So however, keep in your mind, now when you multiply like this by the conjugate, right? When you multiply by the conjugate, or multiply conjugate, so when you multiply by the conjugate, I mean that line that you had the square root, or the square root එක line එක තියෙනවානේ. හරිද? This one, right? There you get difference of two squares always. See, root x plus 5 minus root 7, root x plus 5 plus root 7. So for that one, we can write as difference of two squares. Clear? Okay, next step, we will write it as difference of two squares. So x plus 5 minus root 7 squared means 7. Clear? Over x minus 2, that is this, x tends to 2. So these two I wrote like this. This denominator I wrote here, something remains. What is it? This denominator thing remains. This root x plus 5 plus root 7 in the denominator remains. So you can write it separately as a multiplication. Write it separately as a multiplication always. Clear? Right? So you can simplify it, that's why. You can simplify and you can go for a direct substitution and get the answer. Right? So here, like this we can write. Okay? Now you just direct substitute and see what you get. You substitute 2 here. You don't get any undefined condition when you find limits here. See, when you substitute 2 here, you are getting 2 plus 5. Square root of 2 plus 5 is root 7. So, root 7 plus root 7, 2 root 7. So, we can write 1 over 2 root 7. This part is equal to what? 1 over 2 root 7. Clear? So, now without limits, we can write that part. I will write it here. 1 over 2 root 7. Multiply by limits of, see, x plus 5 minus 7 means what? X minus 2 over x minus 2 when x tends to 2. You can see here we have common factors, method number 1, right? So when you cancel out them, you're getting 1. So limits of 1 when x tends to 2. Limits of a constant when x tends to some value, it is a constant itself, right? Okay, so you're getting 1 there, right? Therefore, this is equal to 1. I mean, this is 1. Limits of 1 when x tends to 2. So the answer is 1. Therefore, your answer will be 1 over 2 root 7. Raise hands also can understand. This is your question number 3 of the TOT. Raise hands also can understand this. So always keep in your mind, very important, when you have roots, you have to multiply by the conjugate, both denominator and numerator. And then what you have to do, the line with the roots, we can just write it as difference of two squares always. And the other things in the sum. However, the other part that remains, or conjugate can multiply part. Now this one we pair, this one remains. That one you just write as a separate limit and then simplify that. Right? So further you don't get this limit part, you're just getting the numerical value as 1 over 2 root 7. You can write it as a multiplication here and just find the limits of this. Clear? Right. Okay. You can have this one soon, and then we'll go move for such questions. New to the tute. Right. Y'all do paper. 3, 3, 4, 5. Sorry, 3 we did. 3 we did right now. Right. You have to do 4, 5, 6 now. Right. 4, 5, 6. Right. I will give you like 6 minutes like to try out. Yeah. Hurry up and find 4, 5, 6. Right. I will give 8 minutes like. Okay. Okay, student, let's start. I will do number 5 first. Okay, number 5 first. Right, so you can see we have square roots in the denominator. You just substitute 0 and c. We will check for direct substitution whether we could do or not. Substitute 0, numerator 0, denominator 0 plus 3, 3. That means root 3 minus root 3, denominator is also 0. 0 over 0. Clear? Right. Now here in this we can't do by a direct substitution. Right. Now what is the next step? When you have square roots, we can multiply both denominator and numerator by the conjugate of the line that you have the square root. Clear? So here root x plus 3 minus root 3, conjugate of that root x plus 3 plus 3. Root x plus 3 plus 3. And here what happens when you multiply these two? Yeah, difference of two squares. Why? Root x plus 3 minus root 3, root x plus 3 plus root 3. Clear? Right? So that means here you have difference of two squares. So we can simplify it further and we can write the denominator as square of this x plus 3 minus 3. Is it clear? Difference of two squares. Limits of x tends to 0. And numerator we have x. Right? So these two we pair and this one also. Something remains, this one, I can write it separately as a multiplication. I will write it separately as a multiplication. I mean, you can write it here, right? Still, we can simplify it now. So let's write it separately. Root x plus 3 plus root 3 when x tends to 0. Okay, what you have in the numerator this time remains. Clear? Right. Now see, 3 minus 3 is 0. Now x over x means what? 1. So now what you have? Limits of 1 when x tends to 0 times, here what is the answer for that? When x tends to 0, when x tends to 0, I will just direct substitute. Here, say 0 plus 3, 3. So root 3 plus root 3, 2 root 3. This times 2 root 3. So here also we get the answer, limits of 1 when x tends to 0, it is 1. Clear? Limits of a constant when x tends to some value is always the constant, same constant. It does not change. Clear? Because x value, this does not depend on the value of x, right? That's why. Right? So limits of this is equal to 1. Right? So we get the answer as 1 times 2 root 3, 2 root 3 as the answer. Correct answers, please. Question number 5. Okay, right. Let's move to this one. Now here we have square roots in both denominator and in the numerator. In this question, we have square roots in both denominator and numerator. Clear? And also, when you substitute directly, say direct substitution, substitute 5 here, root 5 minus root 5, 0. And here also 9 minus 5, it is 4. Square root of 4 means 2. 2 minus 2 again 0. Clear? Right. So, now what we can do? Yeah. We will multiply both denominator and numerator by the conjugate of this one and this one both. Okay? Right. I will do this. See. I'm going to multiply first by the conjugate of this one. What will I get? Yes. Root 9 minus 6 plus 2. Root 9 minus 6 plus 2. Okay. At the same time, I will just multiply by this one also. See. Okay, you can also do it in the next step, it's okay, but I will do it in the same step. Root x plus 5 plus root 5. Root x plus root 5. Clear? Right. Now, pair. This one and this one, they form difference of two squares. This will remain. Okay? Right. This one and this one, they form difference of two squares. This remains. Clear? Right. So now we will write them. See, limits of equals to limits of, take the difference of two, write this as a difference of two squares. We are getting square of this is 9 minus 6 and square of this is 2. Minus 4, I'm sorry, minus 4. Clear? Root 9 minus 6 squared means 9 minus 6 and 2 squared means 2. Right? And the denominator, what comes to the denominator? Root x minus 5, root x plus 5. That one also we can write as x minus 5. Root x squared minus root 5 squared, that is x minus 5. This product is difference, we can write as difference of two squares, a minus b, a plus b. In the format of a difference, I mean these are the factors of difference of two squares, we can write like that. No? So root x minus 5, root x plus 5 we can write as x minus 5. Okay, when x tends to 5. And what I told you in the previous questions, right? What remains once you pair? Okay, once you pair, what remains? You just write separately as a multiplication and put limits. Right? Write them separately. What remains here? I got this. I'll pair this one, and this one. These things remains. I will write it here. Root x plus 5, root 5 over root 9 minus x plus 2. This also remains in the denominator. Clear? Right. Now here you see you can go for a direct substitution. Substitute 5 here. Root 5 plus root 5, 2 root 5. Denominator. Substitute 5 here. 9 minus 5, 4. Root 4 means 2. 2 plus 2, 4. So here we will get the answer as, when you write 2 root 5 over 4. Clear? 2 root 5 over 4. Substitute 5 and get the answer. Substitute 5 and simplify. How about this side? For this one? Yes. Limits of simplify. 9 minus 4 then 5. 5 minus 6. Here we have x minus 5. Numerator we get 5 minus x. Denominator we have x minus 5. I can write this one also as 5 minus x. How? Taking the minus sign out. Take the minus sign out. 5 minus 6. X minus 5 becomes 5 minus x. Take the minus sign out. Okay. Minus. Okay, write it here. Minus 6. Okay. Right. So x tends to 5. Now these two get cancelled. Right. Okay. So what is the answer from this? Limits of minus 1 when x tends to 5. Limits of a constant when x tends to some particular value. The constant itself. So we get minus 1 from this. We minus 1 with a minus 1 then we took a minus 1 out, so that one remains here. Minus 1 times 2 root 5 over 4. This one also further we can simplify. No? So minus root 5 over 2. That is the way we get the answer. Raised hands also can understand this. Now you may have not done this because you have two roots, but I mean both lines you have the square roots. Still you have to follow the same method, right? You have to follow the same method. Okay, I will give another 2 minutes to try number 6 now, right? You have the idea about this, now we can try number 6. Okay, hurry up. Board. There x tends to number 6, x tends to minus 1, x tends to minus 1. Okay, hurry up and do. Okay, right. Now you just, we have to substitute, I mean, when x tends to -1, you substitute -1 and check, right? Substitute -1 and check. See, 8 minus -1 is 9. Square root of 9 is 3. 3 minus 3 is 0. Numerator becomes 0 when you substitute -1. Substitute -1 here. 2 minus 1, 1. Square root of 1 means 1. 1 minus 1, 0. Denominator also becomes 0 when you substitute -1. Clear? So we can't go for a direct substitution. Right. Now this is a question that you have square roots in both denominator and numerator. So what we usually do is we multiply both denominator and numerator by the conjugate of the line that you have the root. Clear? So see, root 8 minus x plus 3, root 8 minus x plus 3. Both denominator and numerator we have to multiply by this. Clear? So in the same question, I mean same line, I will just multiply by this one also. See, multiply both denominator and numerator by conjugate of this one, right? What comes here? Root 2 plus x plus 1, root 2 plus x plus 1. Okay. Now you can pair this one. See, this and this, they form difference of two squares. A minus b, a plus b, difference of two squares. And this form difference of two squares. See, root 2 plus x minus 1, root 2 plus x plus 1. Clear? Therefore, they also we can write as difference of two squares. So first of all, we will write like that. So see, limits of, it is 8 minus x, square of this 8 minus x, minus 3 squared means 9. Clear? I mean this and this we can write as difference of two squares. Root 8 minus x squared means 8 minus x, and minus 3 squared means 9. That's why. Denominator, pair this and this. Then also we can get root 2 plus x squared means 2 plus x, minus 1 squared means 1. When x tends to -1. So when you pair this one, this one, this one and this one, what remains? What remains? These two. We can write, I will separate it there, right? I will separate. See, limits of root 2 plus x plus 1 over root 8 minus x plus 3. When x tends to -1, I will separate it. Is it clear? Right? So this one that we separated, we can go for a direct substitution. See, substitute -1, you don't get any undefined condition. Substitute -1 here, 2 minus 1, 1, square root of 1, 1 plus 1, numerator we get 2 as the answer. Clear? Substitute -1 here, 8 minus -1, 8 plus 1, that is 9, root 9 means 3, 3 plus 3, 6. Can you understand? Right, so we can write this one as just 2 over 6, that's why. From the very first step, we can do it. Okay, no need to continue with the limits until the last step, right? Okay. Now simplify this. 8 minus 9 minus 1, and here we get x plus 1, see? Here this one we get x plus 1. Here we get minus x minus 1 in this line. Minus x, I will take the minus sign out and write minus into x plus 1, right? Limits when x tends to -1. So you can see this x plus 1, this x plus 1, they get cancelled. So we have -1. Limits of -1 when x tends to -1 is the same value, -1, it does not change. Minus into 2 over 6 means with a 1 over 3. Therefore, the answer is -1 over 3. Can I know how many of you got this correct? You should get, right? You should get this correct because we did this kind of one previously, right? 2021. I hope others could understand, right? So if you're a student who didn't get the video, if you haven't covered this, I sent to most of the students, I sent the recordings, I mean like screen recording covering these limits theory things, I mean the concept and theory part, and some questions, example questions like question patterns. Okay, if you didn't get that, please let me know, send a message, then I will send it to you. And again, you can watch the recording of this and then you will understand this well, right? Okay, right. Shall we move to the next question? Shall we? Right. Next question pattern. Let me discuss the next question pattern of these ones. See, doing 7. Yeah, I will move to this later. I will move to number 1, 2 later. I will discuss the sign things, right? We are going to discuss number 7 first. Okay, question number 7 first. Before that, I will just recall the theorem. Okay, look at this. Right. So when you have this format, actually we proved this in the theory class, and also like you have some theorem called sandwich theorem. Using that one, okay, even you don't get the proof of that theorem. We asked just to state the theorem with you all, right? So using that theorem, actually we can prove this one, right? So what you should know is this. What you should know is this: limits of sine x over x when x tends to 0. Limits of sine x over x when x. Okay, you just direct substitute and see. When you substitute 0, sine 0 is 0. Denominator is also 0. You will get 0 over 0. Undefined condition. Clear? Right. So, right. Now when this is what you have to get. This is the summary. This is a summary, right? As this is a revision session, I'm not going to discuss the theory parts, right? We have discussed them in the class. See, limits of sine x over x when x tends to 0, the answer will be 1. Clear? The answer will be 1. So you should have this format, then you can get the answer as 1. What I mean by the format? If the angle here is x, if the angle is x, here also you should have this x, and here also you should have x, right? And this x should tend to 0. Okay, if it satisfies all these 4 conditions actually, then your answer will tend to 1. Okay, so sine x over x when x tends to 0, then your answer will be 1. For example, another example, see, limits of sine 4x, okay, over 4x when 4x tends to 0, then the answer will be 1. Is it clear? Right, this one should be same, and this should tend to 0. Right, and those who can understand the way that you have to form. May vidyat answer one way. Only when you get this kind of a situation, you get the answer as 1 there. You can directly write the answer as 1. No any solvings. Clear? Just you can write the answer directly as 1 once you get this format. Okay, so what we are trying is actually when you get questions, we try to form the format. Clear? Another example, see here, if you have x over 2, let's say sine x over 2, the denominator also you should have x over 2, and here also we should have x over 2. So limits of sine x over 2 over x over 2 when x over 2 tends to 0 will be equal to what? 1. Is it clear? Right. Now let's do the questions. I will do these questions, right? I will do question number 7. I will do question number 7, 8, 9 and like number 12. Okay, 7, 8, 9 and 12, and then you have to continue doing alone. Clear? Right. Let me do 7, 8, 9 and 12 so that you can get a good idea how to solve the questions, right? Solve the problems. Right. So always keep in your mind there should be sine x over x when x tends to 0. Then only we can write the answer as 1. Right. So the first question, I mean question number 7. Question number 7, Pute, you have limits of sine 7x over x when x tends to 0. This is the question given, right? This is question number 7, right? Now is it in the format that we want? What is the format that we want? Sine x over x when x tends to 0. But the angle is not something that we could change. Angle that is always the thing given. Sometimes we can use some formulas and just like if you have sine 2x, then we can write it as 2 sine x cos x. Otherwise, we can't sine 7x, we can't divide the thing inside, we can't divide this by 7 as we want, like that we can't do, no? Right? So what you have to always keep in your mind is, without changing this one, all the other terms you try to form as this. Here 7x, here we have 7x, no? So you try to form other terms as 7x. That's what we have to do. Sine don't try to change the sine, sine angle. That part you can't change actually. Clear? Formula change we can't change it. We have to accept as it is, and then we should try to make the sum as we want from using the other terms, using this and this. Clear? Okay. So however, what should we get to get the answer as 1? Sine 7x over 7x when limits, okay, so when 7x tends to 0, limits of sine 7x over 7x when 7x tends to 0, then only we can write the answer as 1. Clear? Okay, see what I'm going to do now. I want to make this 7x, so I will put 7 here. I'll put 7 here. Okay, I think you can see what I'm writing in blue. All right, write the special cases. Can you see? Yes. Now we had only x. This is a question that you got. Right. Look at this. What I'm going to do is I want 7x. I want here 7x. So I will put 7. But this is wrong then. This should be equal to this, no? So I made a mistake. What is it? I put 7 to the denominator. So I want to remove that. So I will multiply this whole thing by 7. Clear? I mean, multiplying it by 7, you know that we can take the constants out. That's why I wrote it here. Otherwise, here 7 and 7, they get cancelled like that. Now still, this is same as this. Clear? No any mistakes now. No any errors. We have the same line still, like 7 and 7 get cancelled. It is equal to this one. But if you put 7 only, then that's wrong. But if you remove 7 using this, putting it in the numerator, then we can write. Then you see, when x tends to 0, when x get closer to 0, what happens to 7x? Now think, when x get closer to 0, what happens to 7x? 7 times x also get closer to 0, right? So here we can write 7x tends to 0. Here we can write 7x tends to 0. Clear? Now we have got the format sine 7x over 7x when 7x tends to 0. Here what I wrote is x tends to 0 means 7x also tends to 0. No? So that's what I wrote here. Limit. Clear? Okay. So this whole part now I can take as 1. Clear? So 7 into 1, your answer will be 7. Raise hands also can understand. So we are always trying to get the format. That's why I multiplied by 7. Okay. Right. Let's move to number 9 now. number 9. This one. Limits of sine cube x over x cube when x tends to 0. This one. Yes, how can we do this? Right, now look at this. I told you this kind of a rule, right? Limits of gx or limits of fx, limits of fx whole thing squared. If this function is a squared one or else to the power n1, I mean to the power n, if I have mentioned it as 2 in when I'm discussing the theory, I'm not sure. So you have to make it n, right? Any power. If the whole function is to this power to the power n, right, when x tends to some value a, we can write this one as limits of fx when x tends to a whole thing to the power n. Clear? Then my function eකට තමයි මේ power එක දෙන්නේ fx to the power n කියලා තියෙන්නේ. You have fx to the power n, right? So if this is whole function to the power n, we can write, I mean we can find the limits of fx when x tends to a, and then we can get the power of the answer. Clear? We can write this. So how can we do this one then? Here we have sine x whole thing to the power 3 and x to the power 3. So that is this function, I mean the cube of this function. Within sine x over x whole thing cube. No? Raise and those who can see that this is sine x over x whole thing cube. Can you see? So how can we write? We can write it as, we can write like this. Limits of sine x over x to the power 3 when x tends to 0. Clear? If this is whole thing to the power 3 only, if the given function is whole thing to the power 3, then we can write like this. Power 3, power 4, then you can write 4 here like that. Okay, so this part is well known. What is this? 1. So the answer is 1 to the power 3, 1. Clear? So keep in your mind, you have to get the format and write the answer. You have to get the format and then only we can get the final answer. Clear? Okay. So this is question number 9. I think you can do 10 now. I think you can do 10 alone. I will do number 12 also as a help. I will do number 12. Okay, I will give you time to write down these things. Let me explain. You just listen now. Limits of 1 minus cos 4x over x squared. Is it? Yes, x squared. When x tends to 0. This is the question. Right, how can we do this one? 1 minus cos 4x over x squared. You substitute 0 and c. 1 minus cos 4 times 0, 0. Cos 0 means 1. 1 minus 1, 0. Numerator becomes 0. Numerator is 0. Denominator, when x tends to 0, denominator is also 0. Clear? So both denominator and numerator 0 means undefined condition, 0 over 0. Clear? So what we have to do, you have to do something now. Right. If I ask you to write this in terms of sign, somebody please tell me a method to write. Okay, you can just send me a message. What we can do now? I want to write this in terms of sign, the numerator. What are the formulas that we can use? Message. Yes, very good. Yes. Half. Yes, Sakit, my answer is correct. Atufa, correct. Very good. Mariam, I think a new one sometimes. However, your answers are correct. Okay. Those who send the answers, your answers are correct. How about others? Any idea? Gagana? Jayani. Very good, Jayani. Very good. Yashasvi. Yes, correct. Okay, good. Right. I want to write this in terms of sign. You know, cos 4x, we can use half angle formulas. Just recall. Cos 2x, how can we write? Cos 2x, we can write in three ways. We can write it as cos squared x minus sin squared x, or else 2 cos squared x minus 1, or 1 minus 2 sin squared x. Can you remember? Right? So if I need to write cos 4x, what will happen? If it is 4x here, this is 2x, 2x, cos squared 2x minus sin squared 2x. However, half of the angle, what you have here, we have to write. Clear? Right. I will write down this actually such that I can cancel out this 1, and also I can write, I'm going to try, I'm trying to write this in terms of sign. Clear? Because I want to use the rule, I want to use this rule. So I'm going to write it in terms of sign. So we will write like this. Clear? Cos 4x, how can we write? Cos 4x, 1 minus 2 sin squared 2x. Half of 4x is 2x. No? That way. Clear? Right. Okay, look at this. Limits of, this is equal to limits of 1 minus, instead of cos 4x, we can write 1 minus 2 sin squared 2x. Okay, over x squared when x tends to 0. We can simplify this. 1 minus 1, minus 1, 1 minus 1, 0. Minus into minus, plus. So we have plus 2 sin squared 2x. So we have like this, limits of 2 sin squared 2x over x squared when x tends to 0. So something very nice. Look at this. When you have constants, we can take them out of the limits and write. When we can write it here, 2 times limits, like that we can write. Okay, so we can take it out. When you take it out, what will happen? I mean, when you don't have this 2 now, I will write 2 here. What will happen now? Numerator also you have a squared term, denominator also you have a squared term, so you can write it as a whole thing squared like this. Clear? Okay, let's do like that. I will take 2 out first. What remains is sin squared 2x, x squared. So I will write whole thing. I will put limit to the whole thing. Say limits, I mean, I will put squared to the whole thing and get the limits. Say limits of what? As I put squared here, now we can have to write it as sin 2x over x. Is it clear? Now we have to write it as sin 2x over x. Now what we can do? Is it the format limits of sin 2x over 2x when 2x tends to 0? If it is a format, it should be like that. Limits of sin 2x over 2x when 2x tends to 0. But it is not that way. So what we can do? Here it is 2x now. I will make it 2 here. I will put a 2 here. And to remove that 2, I will put a 2 here. Not outside this. Clear? 2 and 2 should get cancelled because here this is a squared. You can't take out of that. If you take out of that, you have to write 4. Okay? Right. However, like this we will get. And then, you know, when x get closer to 0, then definitely 2x also get closer to 0. Now we got the, see, limits of sin 2x over 2x when 2x tends to 0. So this part is equal to 1. Clear? So now this is 2 times 2 squared. 2 times 2 squared means 2 times 4, that is 8. Can you understand? So now I look at this. We have 1 minus cos 4x over x squared. I used this one, very important. We usually use this. We usually use Okay, so 11. Right. Now listen me. So this is very important. This is, I mean, you can just keep this in mind. We usually use this method, right? Writing this cos things in terms of sign, not always, depending on the question you may use. Clear? Right. So usually we will get these kind of things. So 1 minus 1, it is 0. Minus into minus, it is plus. We have 2 sine squared 2x over x squared. We can take constant terms out. Sorry. Uh, Yeah, we can take the constant terms out. So 2 there. And we now what remains? Sine squared 2x and x squared. Clear? Sine squared 2x and x squared. Now you have sine squared x squared, all things squared. So we can write limits without this one, without the squares, we can write sine 2x over x, limits of sine 2x over x when x is 0, whole things squared. We can get like that. Clear? So then what did I do? Now we have limits of sine 2x over x, but I want to make it 2x over 2x. So I put a 2, I remove the 2. I put a 2, I remove the 2 to make the mistake. Clear? Then when x get closer to 0, 2x also get closer. Now it is a format, limits of sine 2x over 2x when 2x tends to 0. This is equal to 1. Clear? So now it is 2 squared and 2. We get it. Very easy, very nice, right? I hope you can understand these methods. Okay. Here we use different tricks. Okay, right. So first case, when you have 7x, making this 7, making this one also 7x and 7x tends to 0. That is the first case. Here, cube, cube, whole thing cube. Okay, and then we can get this separately and get the answer as 1 to the power 3 and 1. Clear? And this we have used both these things, first one and second one, both we have used in the last one, and also we used a special trick there, writing cos 4x in terms of sine and then using the theorem. Clear? Right. Raise hand those who can understand all three very well. Okay, if you have doubts, you can just tell. Right, you can note down these things. Okay, you can note down these things soon. Then I will give you questions to try along. Raise hands. Raise hands also still writing, Lamai? Raise hands also still writing? Okay, shall we move to the next question? Right. Okay. Two. Y'all do number 8, number 10, and also you'll all try number 11 also. I will give you a hint to do number 11. You will try number 11 and 13 also. 11, 13. Okay. I will give you a hint to do 11 and 13. You can divide. This is a fraction. So you can divide both denominator and numerator by common terms, right? I mean, you can get equivalent fractions by dividing by the same thing. So try to get the format. Try to get the format sin x over x when x tends to 0, right? So then you will understand from which term you can divide both denominator and numerator to get the format. Okay, that is the hint. Do all the questions. I mean, 7, 9, and 12 we did, no? 7, 9, and 12. Do the rest of the things. 8 that you can see on the screen. 8, 10, 11, and 13. 8, 10, 11, and 13. Okay, right, start. Okay, Lamai. We'll start from this number 8. Number 8. Right? It's very simple question. Right? You can see x is the common denominator of this one and this one both. So we can write this as sine 9x over x, sine x over x. X is the common denominator. And then we know this rule, this property of limits. Limits of fx plus gx when x tends to 0. When you have a sum, we can separately write them as an addition. Say limits of fx, right, when x tends to 0 plus limits of gx when x tends to 0. We can write like this. Okay, right? So this one also we can separate. First we have to write this as sum of two fractions sine 9x over x, sine x over x, because x is the common denominator. Then see limits of sine 9x over x when x tends to 0 plus limits of sine x over x when x tends to 0. Clear? Because x is the common denominator. That's why. Right. Now, this one this is the rule, this is the theorem. Sine x over x when x tends to 0, it is equal to 1. Limits of sine x over x when x tends to 0, it is equal to 1. How about this one? This side is not in the format. Sine 9x, if it is in the format, that should be sine 9x over 9x when 9x tends to 0. So you just make it 9x. Denominator 9x, but I did a mistake. I had to make the mistake, right? I mean, I had to remove that 9, right? I have to remove the 9 that I added here. Clear? So limits of sine 9x over 9x when x tends to 0 means what? 9x also definitely tends to 0. Clear? So this whole part is also again equal to 1. Now 9 times 1, 9, 9 plus, here this part is 1, no? So 9 plus 1, 10. The answer is 10. Clear? That is the way to do that one. Right? Very easy. The next one. This question. Look at this. Sine to the power 4 2x, x to the power 4. Limits of when x tends to 0. So this is also to the power 4. This is all to the power. This one actually we can write this as all thing to the power 4. Write without the power 4. Write without this y'all. Sine 2x over x. Right? X tends to 0. Now you can write whole thing to the power 4. Okay, right, try to make the format here. See, sine 2x, if it is in the format, if it is in the correct format, what should be? This sine 2x over 2x when 2x tends to 0. Clear? Right, but we don't have a 2x here. I will make 2, remove 2. Okay, 2, they get cancelled back to the same thing that you had previously. Right, you can't change the sum. So, 2x connect with that is wrong. Clear? Dividing by 2, you're putting 2 to the denominator means you're dividing by 2 now. So we don't have a 2 in the denominator in the original question, right? So when you put a 2, we have to remove 2. Okay, right now sine 2x over 2x when x tends to 0 means definitely 2x also get closer to 0. When x value get closer to 0, 2x also get closer to 0. That's why we are writing like that. Okay, so this whole part now it is equal to 1. So 2 to the power 4 means 16. Clear? Right. Can I please know whether you Rayson also got this one correct? These two, first two. Got the answers of the first two. Most of you have got, no? I hope others can understand too. Now, right. Try to understand the way that we are doing the sums. This is also a very simple question, right? Next question, I will give time to write. I will just do all the questions and then I will let you write, okay? Right. Next question, this one. This one, how to do? Yes, how to do this? Oh, I'm sorry. This should be limits of x tends to 0. Here also the same. Right. This one, how to do? Now it is sine 7x minus sine 2x, and denominator also we have sine 3x, and here we have 4x. When you substitute 0, this will become sine 0, sine 0, sine 0, 4 times 0 also 0, 0 over 0. Clear? Right. I think we can't do this that way, right? We can't go for a direct substitution. Right. So what I'm going to do is, I feel like it's better if I have this sine 7x over 7x here, sine 2x over 2x, sine 3x over 3x, like this. Clear? So I'm going to divide both denominator and numerator of this fraction by x. Both denominator and numerator by x. That means dividing each and every term of this fraction by x. Right? Dividing this whole thing by x means this one and this one we have to divide by x. Dividing this whole denominator by x means what? This and this both we have to divide by x. Okay, let's divide them and write. See, limits of sine 7x over x minus sine 2x over x over sine 3x over x plus 4x over x. Clear? Did I do any mistake? Did I do anything wrong? No. I divided. See, these things also, when you multiply by the reciprocal, again x and x will get cancelled. These are equivalent fractions, so we can divide both numerator and numerator by the same number, no problem. Clear? Right. Now I can just put the limits separately to this numerator and the denominator. You know, we have fractions, we can get the limits of this one and this one separately if the denominator is not equal to 0. There is a condition, but here you can see the denominator never gets 0 when you find limits, right? Okay. Separately give the limits to each and everything. Limits of sine 7x over x when x tends to 0 minus limits of sine 2x over x when x tends to 0 over limits of sine 3x over x when x tends to 0 minus limits of 4 when x tends to 0. And x and x I cancel them. So we need limits of 4 when x tends to 0. So for there, try to make the format here. Make it 7x sine 7x over 7x. So I put a 7. You don't have a 7, so multiply by 7 when 7x tends to 0. Clear? You can write separately when 7x tends to 0. Here also the same, sine 2x over 2x when 2x tends to 0. We put a 2 here, remove that 2. Extra 2, remove that 2. Right? Here, sine 3x, make it 3x. Remove 3. Clear? No mistakes. No any errors, right? So 3x also tends to 0. Likewise. Right? So you know this part is equal to 1, this is also equal to 1, and this tends to what? This tends to what? Limits of 4 when x tends to 0. Whatever the value that x tends, 4. I mean, it does not matter the thing that 4 tends to 4. Clear? So the answer from this is 4. Answer from this is 3, 7, 2. So this is actually, can you see? This is 7 minus 2 over 3 minus 4. Okay, 7 minus 2, it is 5 over 3 minus 4, it is minus 1. So the answer is minus 5. The answer is minus 5. That is the way we get, right? Okay, the last one. Okay, I will give you more time to do last one. No need. We will do more questions now today. I will do this one. Right. 1 minus cos 8x. Can you remember the previous question we did? I think number 12. We did, right? 1 minus cos 8x. I can write this in terms of sine. Wait, denominator 3 plus. Yes, denominator should be 3 plus 1. Thank you, Pamit. That should be so 5 over 7. The answer is 5 over 7. Thank you. How about this one? How can we do this? I can write this one also in terms of sign, because here also you get an undefined condition. See, when you substitute 0, 8, cos 0 means 1. Cos 0 means 1. 1 minus 1, 1 minus 1, 0 over 0. Right. I can write cos 8x as limits of 1 minus, how can I write cos 8x? Yes, how can I write cos 8x? 1 minus 2 sine squared 4x, half angle formula. Denominator also you put the half angle formula, same thing, 1 over 1 minus 2 sine squared, this is 2x, this time it is x, like this, when x tends to 0. Clear? 1, 1, 1, 1 they get cancelled, minus into minus plus, minus into minus plus. 2 and 2 then they will get cancelled, you know, right? Because now it is this limits of 2 sine squared 4x. Take them out and write the limits if you want. Okay, otherwise you can see that they get cancelled, right? Sine squared 4x, and here also we are in sine x. 2 sine squared x, x tends to 0. This is the way we get. So what happens? This 2 and this 2 they get cancelled. Now you can see this is also a squared term, this is also a squared term, so I can write this whole thing squared. Okay, you just continue writing the answer. You complete the answer here. You know, this one you can write as whole thing squared. Then we have sine 4x and sine x here. You will feel better if you have sine x 4x over 4x sine x over x. So you think what you have to do. Okay, complete this. All of you complete the things. Raise hand those who can understand what we did up to now. Yeah, there are 33 students, only 15 can understand. Raise hand those who can understand. කම්මැලි වෙන්න එපා raise hand කරන්න. දැන් teacher බලාගන්නනේ. කී දෙනෙක්ට තේරුණාද කියලා. 25. Okay. If you have any doubt, you can ask, right? Okay, if you have done the last one, you can send the answers that you got. You can share your answers with me. Answers to problem. Okay, some of you have got the answer as 16, some of you have got the answer as 4, let's see, right?
It sounds like we have a bit of a debate happening with those.
Okay, here we have sine squared 4x, sine squared x. I will take this as, because both squads now 2 also 2 and 2 also get cancelled. So I will write like this, see. Limits of sine 4x over x, sorry, sine 4x over sine x. Right? We can go for this kind of a line. Then, let me do it here. Okay, I will continue writing here. Right, look at this. So we have this, and then you should feel like this. You should feel better if you have. You have to think like if I have sine 4x over 4x here, if I have sine x over x here, clear? So I will divide both denominator and numerator of this fraction by x. Right? As my first task, I will divide both denominator and numerator by of the given fraction by x. See? Sine 4x over x sine x over x. Like this we can write. Clear? Right? So however, this whole thing squared. This whole thing squared. This is not something complex. Just try split into 2. This one and this one I divided by x, that's all. Right? Now we can give the limits separately to these two. Right? Equals, see, equals. However, final answer we had to score. Final answer we had to score. Limits of sine 4x over x when x tends to 0 over limits of sine x over x when x tends to 0. We can write it like this. Denominator, you can say denominator is equal to 1. However, the numerator still it is not equal to 1. You can say it is sine 4x, make it 4x, remove 4. Okay, sine 4x over 4x when 4x tends to 0. When x tends to 0, when 4x also tends to 0. I mean, when x get closer to 0, 4x get closer to 0. That's why, right? Therefore, now this whole part is equal to 1. This part is 1. This part is 1. You have just 4 in the numerator. 4 squared means 16. Can you understand? right? Okay. Pamit, can you understand Pute? Yes. And how about the others? There was another one who got 4 as the answer. Yes, no, others got the answer correctly. Okay, good. Okay. Sakit, I hope you can understand it now. Ne? Right. So there is a way to do that question. Okay, now we will move to some more questions. Now you can understand, I think, the way to do, right? Right. So you are usually getting questions. When you get questions, usually you get 2 or 3 properties to use. Clear? 2 or 3 properties to use. I mean, question patterns, right? You will have roots. Will have common factors. You will have sin x over x rule. In the same question, you will have all these things, right? However, whatever the thing that you get, you have to just they don't like make it a mess. Simply solve them step by step that in the way that I have guided. Right. Let's move to the next questions. Okay. Now here it is with the square root also. You will try alone this 14 and yeah, better to try alone 14 and 15. I have asked, I taught you what is the step you have to follow when you have roots, right? Okay, do 14 and 15 now. 14, 15. 14, 15, 16. 16 is actually easy. It's okay. Do 16 also. 14, 15, 16. 14, 15, 16. Okay, let's try this question. Right, let's try this question. Here it is a question with the square roots, right? You just substitute 0 and c. You substitute 0 and c as your first step, right? 2 plus sine 0 means 0. So square root of 2 minus, here also 2 minus sine 0, that is also square root of 2. Root 2 minus root 2 means 0. Numerator is 0 when you substitute x direct. I mean, when you go for a direct substitution, numerator becomes 0. You can say denominator also will become 0. Okay. So, what I have asked you to do when you have roots, yes, we have to multiply both denominator and numerator by the conjugate of the line that you have the square root. Okay, right. So, this is 2 plus sin x plus square root of 2 minus sin x over root 2 plus sin x plus root 2 minus sin x. Both denominator and numerator you have to multiply by the conjugate of the line that you have this square root. Clear? Right. Now what will happen? These two, what is it? A minus b, a plus b. See, 2 root 2 plus sin x, I mean square root of 2 plus sin x minus square root of 2 minus sin x, and here we have the sum of those two. So we can write them as difference of two squares. Clear? We can write the numerator. What you have in the numerator in this question actually? Okay. What you have in the numerator, this part we can simplify and further write like this. Limits of, see, square of this 2 plus sin x minus square of this 2 minus sin x. We can write as difference of two squares. This one squared minus this one squared. Clear? So what happens is you don't get the root. That's all. Right? Over x when x tends to 0. Clear? Then I ask you, now when you pair this one and when you write this will always remain. What? The other conjugate part will always remain. So write that separately as a multiplication. See, limits of 1 over, it is in the denominator, no? This one is in the denominator. So you have to write it as 1 over root 2 plus sin x plus 2 minus sin x when x tends to 0. Clear? Now put a look at this. This one actually we can directly substitute and get the answer from this. Clear? Substitute 0. Sin 0 will become 0, sin 0 will become 0. So here what we get is root 2 plus root 2, which is equal to 2 root 2. So we get 1 over 2 root 2 here. This is equal to root 2 plus root 2. When you substitute x equals 0, you get sin 0, sin 0, sin 0 means 0. Clear? So root 2 plus root 2 means 2 root 2. And how come this? See, 2 minus 2, 2 minus 2 will get cancelled. Sin x minus sin x means what? Plus sin x. Sin x plus sin x, 2 sin x, right? 2 sin x. So limits of 2 sin x. See how I wrote 2? 2 is a constant. We can take it out now. Over x when x tends to 0. Clear? 2 sin x over x tends to 0. I took 2 out and I mean to get the format actually. We can get the constants out of the limit sign. So this is equal to 1. What you have here is now 2 times 1 over 2 root 2, which is equal to 1 over root 2. Correct answers, please. Yeshant also got the correct answer. Very good. What a pen, let's check. Dulna, can you understand, Pute? Dulna? Dulna. How about Gagana? Okay. Right, so it is always the same thing what you have to do, right? We just multiply by this, and always we can pair this and make difference of 2 squares, and what remains you can separately apply. I mean, we are just separating it as a product. This is a multiplication, this thing times this. Clear? So I multiply, separate them and put limits. That's what I do. And then for this part, actually, you don't get any undefined conditions. You can directly substitute and get the answer from this. No need to continue it until the last step. Some students do that. That's wrong. That's not, I mean, not wrong, actually useless. Wasting time. Make a method. This one, right? There, how to do? There also, I will multiply both the numerator and numerator by this conjugate of this one, right? Conjugate of this. See, root 7 plus sine squared x plus root 7. Root 7 plus sine squared x plus root 7. Now what will happen? This one, right? This term into this term, they are this minus a minus b, a plus b. We can write it as difference of 2 squares, isn't it? So how can I write? Limits of, okay, first term squared, what is it? 7 plus sine squared x minus second term squared 7. Clear? We are writing as difference of 2 squares. This minus this. Right? A minus b, we can write as a squared minus b squared. No, that's what I did here. Right? Over x squared, this x squared, when x tends to 0. Okay, times, don't forget, you wrote this one, you wrote this here. This one remains, this denominator remains. Right now, I can write it, I will put limits to that one separately. Limits of what? 1 over square root of 7 plus sine squared x plus root 7. Okay, you can see this thing when we separate multiplication. So this part, actually, when you substitute 0, you can get the answer. You substitute 0 here. Sine squared 0 means what? Sine 0 means what? 0. So sine squared 0 is also 0. Square root of 7 plus square root of 7, 1 over 2 root 7. This is equal to 1 over 2 root 7. Clear? Here 7 and 7, they get cancelled. 7 minus 7. Now we can write this 1 over root 2 7 here, 1 over 2 root 7 times this part. I just got it to the front. What remains when you cancel out 7 and 7? Sine squared x over x squared. Both are squared terms. So I can write this as the whole thing squared and take the limits of sine x over x. Clear? Why did I do like that? Because now 7 is when you cancel out 7 and 7, I mean when they get subtracted, it becomes 0. So what remains is sine squared x in the numerator and x squared in the denominator. Numerator, denominator. Clear? Both are squared terms, means this is actually whole thing squared. So you can write sine x over x, limits when x tends to 0, whole thing squared. This is equal to 1. Therefore the answer is 1 over 2 root 7. That's how it, very easy. Right? This one is actually similar question we did previously. Right? We did a similar question previously. So you should get the answer as 7 plus 4 minus 5, 4 minus 3. Okay. You have to simplify. Divide all the terms by x. Divide all the terms by x and put limits separately to each of these terms. We did a similar question in, so I'm not going to waste time there. We did a similar question in question number 11. No? Question number 11. Here you get the answer as 7 plus 4 minus 5. You can't write the answers directly. You have to solve and get the answers. Okay. As it takes time, I will just write the answer. You just get it alone later and check whether if you got the correct answer. 7 plus 6, 1. Therefore, the answer is 6. Resan got 6 here. Once you simplify, 6 as the answer. Divide both numerator and numerator by x. divide both denominator and numerator by x, and then give limits to each and every term. Okay, Lamai, now we all do this question number 17, 18 and 19. 17, 18 and 19. Next, actually, we can write as sin x over cos x, you know, right? Tan, we can write as sin x over cos x, that is a hint. Okay, you can continue. Lesson also finished? Okay, you can try 20, 1, 20 and 21. 20 and 21. Okay, students, how to do this question? Now, this one actually is better if you have a squad in this sign squad 3x. But yeah, I will tell you when it is like this. Actually, in this question, you will get that limits does not exist. The beginning I told you about this left hand limits and the right hand limits. Okay, I told you that the limits exist for a certain function. when x tends to some particular value, if only if the positive, I mean left hand side and right hand side limits to that particular point is same, then only the limits exist, right? Well, look at this one. Here, if it is squared, actually we can solve and get an answer, but here we can't get an answer, right? Actually mistake, it's okay. If you get this way, I will tell you how to do. See, now it is 1 minus cos 2x. We know that cos 2x equals to 1 minus 2 sine squared x. So this one actually we can write as 2 sine squared x. Now you know that. This one it is 2 sine squared x. Instead of this, I can write 2 sine squared x. Plus sine 3x also I will write in terms of, because it is just a 3x there, I will write this in terms of sine x, right? So what is it? 3 sine x minus 4 sine cube x. Can you remember? Sine 3x means the 3 sine x minus 4 sine cube x, right? Limits when x tends to 0. So you can see, I can divide all the terms by sine squared x here. So this sine squared x is common denominator to all. We will get like this, 2 sine squared x over sine squared x, 2, plus 3 sine x over sine squared x, 3 over sine x. Okay, and here we will get minus 4 sine x. Minus 4 sine x. Limits when x tends to 0. This is the way we get. Now you just direct substitute and see. Here, from this one we can get the answer as 2. Limits of 2 when x tends to 0, we get in 2. And limits of 4 sine x when x tends to 0, we will get 0. When x get closer to 0, sine x get closer to 0, sine 0, 0. So from this one we get the answer as 0. When x tends to 0. But from this one what will happen? When x tends to 0, sine x tends to 0. Sine x tends to 0 means this denominator tends to 0. Clear? So we are getting an infinite something there, but in this case we can tell like this, when x tends to 0 from plus side, the sin x curve, see sin x curve is something like this, right? So when x tends to 0 from the minus side, see when x get closer to 0 from the minus side, sin values they are negative. Sin x is negative. Sin x is negative. When x value tends to 0 from this side, left hand side, when x tends to 0 from the positive side, sin x is positive. Okay, so then 3 over this one, here it, as the sin x value is a negative, they get closer to the negative infinity. 3 over sin x, we have when we divide by a negative something, right? So sin x is negative, but when it is getting closer to 0, sin x getting closer to 0 now. Clear? Sin x getting closer to 0 now. So the answer tends to infinity, to which infinity, as sin x is negative here. As sin x is negative here, 3 over sin x will tend to minus infinity. But here as sin x is positive, 3 over sin x will tend to plus infinity. So these limits are not same. Right? As these limits are not same, we say that limits does not exist. Therefore, limits does not exist. They are different. Here which is minus infinity, here it is plus infinity. So limits does not exist. This question will be nice when you put a squad here. You can actually get the answer. Okay, we can get the answer when you have a squad. You just write it. They are squad. And can racers also can understand this one? Right? When x values get closer to this point 0, see sin x is negative. Sin x is negative. So sin x negative sin x negative li thamai ara 0 lang wenne. 0 lang wenakode value infinity wenamane 3. When the denominator tends to 0, the answer is infinity. But here as sin x is negative, it will be negative infinity. When we get closer from the right hand side, we will get positive infinity. Two different things. Clear? So for that value, the limits does not exist. Clear? For the whole thing we can't write the answer. That's why. But if you put a squad here, this will be, you can solve this like this. Actually a printing mistake, okay? You usually get the questions that you can find the limits. Let's continue writing like this. See, sine squad 3x. Yeah, then also you will find the same problem. Now you can divide both the denominator and numerator by x squared. No? Now you can divide both the denominator and numerator by x squared. Divide all the terms by x squared, or else you can do like this also. You can look at this, limits of 2 times, okay, look at this, 2 times sine squared x over sine squared x when x tends to 0. I changed the question, I put the squared here, right, plus limits of sine squared 3x over sine squared x when x tends to 0. This is the common denominator, give the denominator this, denominator this. So this is 1, therefore the answer will be 2. Plus this one, here also we have a squared, here also we have a squared, so I will divide both denominator and numerator by x squared. Put the limits of, see, sine 3x over x squared when x tends to 0, divide by limits of sine squared x over x squared when x tends to 0. I didn't do anything wrong here, right? Because I divided all the terms by x squared and wrote the limits, dividing both denominator and numerator by the same number, right? Then 2 plus, see, scores, we can write limits of sine 3x over x when x tends to 0, whole thing squared, over limits of sine x over x when x tends to 0, whole thing squared. This is equal to 1. This one multiplied by 3 here. Then this part is 1 now again, 3x tends to 0. This is 1. So 3 squared means 9. 2 plus 3 squared over 1. 2 plus 9. 11. We can get the answer like this. Making this squared, we can get the answer like this. Clear? Otherwise, we don't get any, limits. Limits does not exist. We get the answer as limits does not exist in the previous way. Clear? So you make it squared there. Understand this one? Here it's just common denominator. So sine squared x over sine squared is 1, right? So limits of 1 when x tends to 0 is 1. 1 times 2, 2. That's how I got this. And this part, here also is squared. Here also is squared. We can write sine 3x over sine x whole thing squared and divide all the terms by x. Right? You can get this as sine 3x over sine x whole thing squared. Put the limits and divide by x. I here divided by x squared, that is also okay. Okay, let's move to the next question now. Am I correct? Yes, this one. Okay, students, look at this. Lamai. How can I write tan 2x? I mean, how can I write tan x? Sin x over cos x. So this one we can write like this. Limits of sin squared 2x over cos squared 2x. Clear? Sin squared 2x over cos squared 2x. Tan squared 2x, you can write like this. When x tends to 0 over x squared. You just substitute the values and see. When you substitute 0 here, sin 0 is 0. Cos 0, what is cos squared 2x, 2 times 0 is 0. What is cos 0? Cos 0 equals 1. I mean, from this one we can get a value. From this one, when you substitute 0, we can get a value nicely. I mean, not 0, which is not 0. And here again it is 0. So this will be 0 over 0 because of this one and this one, see. Because of sin squared 2x and x squared, this becomes 0 and 0. 0 over 0. So I will just separate it like this, see. Limits of sin squared 2x over x squared when x tends to 0 times limits of 1 over cos squared 2x when x tends to 0. Clear? We can write as a multiplication. So I will separate it like this. Because here we get the answer. Right? What is it? When you substitute 0, this is cos 2 times 0 means cos 0. Cos 0 means 1. This is 1 over 1. So this part is equal to 1. Rest also can understand how I did it. Can you understand why I separated? Then this is very easy then. Clear? When you separate into parts, but මෙහෙම ලියන්නේ නැහැ හරිද දැන් මෙහෙම මේක x squared එකට තව එක්කෙනෙක් ලියනවා එහෙම ලියන්නේ නැහැ දැන් sin 2x over x squared, you know, we have to get it together. Clear? To apply the theorem. Otherwise we will get 0 over 0 condition here and here separately. Right? We are not doing like that. But here this time, this one we can separate and write very nicely. We can get the answer from there. And this one we can write in. Now this one, you can just forget we have one here. See, this is also squared term. This is also squared term. So I can write the whole thing squared. Limits of sin 2x over x when x tends to 0. Because I put whole thing squared here. තේරෙනවද ළමයි මතක තියාගන්න මෙහෙම නෙමෙයි whole thing squared දාන්නේ. හරිද? limit එකටම දාන්න. So whole thing. It is sin 2x. I want to make it sin 2x over 2x. We don't have a 2, so put 2 here to remove that again. When x tends to 0 means 2x also tends to 0. So this whole part is equal to 1 now. Clear? Therefore, 2 squared is equal to what? 4. 2 squared equals to what? 4. Raise hands also can understand this. Amit, you send your answer. I will just go through that. Okay, the way you got the answers 5. Okay. You can note down these ones are very important. Okay. And it is tan. How can we solve it? Raisa also found the answer for this one. Yes, Atufa, can you share your answer with me? Can you tell me what you got as answer? Someone, those who got the answer of this. Very good, Atufa. How about others? Minidu, what is your answer? Minidu. Can you please share your method, Minidu? For this one? Or did you get that answer? Right. Look at this, all of you. So first step, as my first step, I always tell you by direct substitution that you can't get, I mean, you get undefined conditions likewise. I substitute and tell. Okay. Right. So, this one, substitute and say 0. X chord is 0. Substitute here 2 plus, what is tan 0? 0 minus root 2. When you direct substitute here, you will get 0 over 2 plus 0 minus root 2, which is equal to 0 over 2 minus root 2. This is a fraction where numerator is 0, therefore the answer is 0. Clear? Is it an undefined condition? Answer is 0 when you clear? Right? So this one actually we can get the answer by direct substitution. Guys, and those who can understand? This is the answer. Very simple. You don't get any undefined condition when you direct substitute. They are lazy. Right? Okay. Just by this, can you understand? Right. So when you substitute 0 plus 2 over 0 minus 0 over 2 minus root 2 means 0 and 0 is 0 means 0, right? It is not something undefined in mathematics. Right. So we can just get this answer. Direct substitution in answer right. Now number 20. Number 20, and I will continue doing the sums now, right? Because otherwise we won't be able to do the whole stuff. I think I also won't be able to do the whole thing. It's 8:20, 43 now, but I will continue doing, okay, as much as I can. So this is a very good one. When you do this whole tude, you will be able to answer any question, right? Any question that you get. You can just try the past questions now. Definitely you can do, right? Right, now this number 20. 20 is like this. 1 minus x sine 3x plus cos 4x over x squared. Let me make it 2x, right? For example, minus, so it's minus. Yeah, it's minus. Limits when x tends to 0. Then identify 1 minus cos 4x. 1 minus cos 4x. What is cos 4x? 1 minus 2 sine squared 2x. Clear? So 1 minus x sine 3x minus, instead of cos x 4x for there, I can write 1 minus 2 sine squared 2x this time. Half of 4x is 2x. 1 minus 2 sine squared 2x. Divide by x squared. This one and this one, they will get cancelled. 1 minus 1 is 0. Clear? So we get in minus x sine 3x and this plus 2 sine squared 2x. Clear? Limits of minus x sine 3x. I will write like this. I will take the minus 1 out. Minus x sine 3x. X tends to 0 over x squared. And here minus into minus plus 2. I will take 2 out and write. Limits of sine squared 2x over x squared when x tends to 0. Can you understand this line? Then just simplify karagene anagamma the steps adu karakara liyan then tika. I'm not writing the whole see. We can reduce steps actually, but we have to mention all the important steps. But simplification things we can reduce steps now. See now here x squared is the common denominator. So I can give it to this one and this one both. So I wrote like this, say minus 1. We can take it out of the limit sign because it's a constant minus 1. Take it out. Limits x sine 3x over x squared when x tends to 0. And take minus into minus, it is plus 2, 2 out. Limits of sine squared 2x over x squared when x tends to 0. Is it clear? Right. Now x common factors cancel it out. Right, x and x we can cancel. Then what we have here, minus limits of sine 3x over x when x tends to 0 plus 2. Can you see here we have both terms as cos. In the number cos whole thing squared. Limits of, right, without this cos, sine 2x over x when x tends to 0. Okay, now try to get the formats that we need. Try to get the format. See, sine 3x over 3x. 3, remove 3. Remove the new 3 that you added. So, limits of sine 3x over 3x, x tends to 0, we can write as 3x tends to 0. When x tends to 0, 3x also tends to 0. That's right. Sine 2x over 2x, when x tends to 0, 2x tends to 0, and you have to remove this 2 that you added. Sorry. You have to remove this 2, you have added. So this part is equal to 1, Pute. And this part is also equal to 1. Clear? So here is minus 3 times 1 minus 3. And here 2 into 2 squared, that is plus 8. Okay? Plus 8. And then we get the answer as plus 5. No? I think also if you got the answer as 5. Can I please... can you raise hands if you got the answer as 5, please? Well, only. How about others? Raise hands, all those who got the correct answer, please. Or maybe you are still doing, right? Raise hands, those who can understand this very well. Okay. Now I will do 21, 22, and 23. Okay. You all just go through the paper. I mean, the tute. Okay. Yeah, I will give you one. Sorry, I will give you 1 minute to write the answer, please. 1 minute, like, yeah. Hurry up and write the answer. Those who need. Do your corrections if wrong. Paper. Right, we will do these questions, right? Don't get like these are very. Yeah, can you please tell me some method to do these ones? 1 minus cos 4 sin x, x squared. What can we do? These four all are same type questions. Yes. Cos 4 sin x. That is just not like cos x into 4 sin x, not like that. This is cos 4 sin x. Okay, look at the board now. See? Number 21. There it is, limits of 1 minus 4, cos 4 sin x. Cos 4 sin x. Okay? Divide by x squared when x tends to 0. This is the question. Right? How can we do this now? 1 minus cos 4 sin x. Yes. But then we can write down like this, no? Limits of 1 minus, I can write this in terms of sign, you know, right? We can write this using half angle formulas. It is 4 sin x here. I can write this as, now 4x. Then how are you going to write? 1 minus 2 sin squared 2x. So same as that. Right? Same as that. Sorry. 1 minus 2 sin squared 2 sin x. Here the angle is 4 sin x, even in terms of like 4 sin x, but here it is half of it. Raise hand those who can understand how I wrote it. Maybe like half angle kitille. Or the 4x tibana the 2 sines got 2x same as that. So it is cos 4 sin x. Now here 2 sines got 2 sin x. Clear? Using half angle formulas. Right, over x squared. When x tends to 0. Now this one and this one will get cancelled. Minus into minus plus and 2 I will take it out. 2 limits of, we have sine squared 2 sin x over x squared when x tends to 0. I hope you can understand this line. Minus into minus plus 2 I took it out of the limit sign, then I mean out of the limits. We can find limits of this one only. Limits of sine squared 2 sin x over x squared x tends to 0. Can you see here also we have a squared term, denominator also we have a squared term. We can write this as whole thing squared. Let's write like that. See, equals to 2 limits of, without limits, 2 sin x over x when x tends to 0 whole thing squared. Clear? Right. Now what we can do? Yes. What can we do now? Lamai, to get the format, to get the method that we use, what is it? Limits of sin x over x when x tends to 0. Right? I will do something like this. See. 2. How things squared. Remember teacher karana limits of, see, put a copy when see, sine 2 sin x. So I feel better than if you have a 2 sin x here in the denominator. Can you understand? X tends to 0, limits x tends to 0. Sine 2 sine x over 2 sine x when 2 sine x tends to 0. That's what I want to form. Sine x over x and x tends to 0. This time this is 2 sine x. So I told you previously, always try to form this thing. Clear? Using this one, you try to form the format. Clear? So it is 2 sine x here, sine 2 sine x. So sine 2 sine x over 2 sine x. Like that. So this is some extra part that I put to the question, no? So I will remove that using this 2 sine x here. Clear? Now you can see, see this is very nice. See, 2, whole thing squared. I can write the limits separately. Now this is, I mean this whole thing limits. So this is a multiplication. I can write the limits separately. See, limits of sine 2 sine x over 2 sine x when x tends to 0 times limits of, I mean 2, take it out, 2 into limits of, this 2 I took out, 2 into limits of sine x over x when x tends to 0. Writing as a product, now limits of fx into gx, we can write as limits of fx times limits of gx. Like that I separately wrote limits for each. Look at this, Pude. Limits of sine 2 sine x over 2 sine x when 2 sine x tends to 0. When on format when x get closer to 0, sine x, sine 0, sine x also gets 0. So 2 sine x also get 10, 2 sine x also tends to 0. Now look at this, limits of sine 2 sine x over 2 sine x when 2 sine x tends to 0. Clear? So this whole part I can take it as 1 now. Right? How about this? Well known 1. Right? So we get the answers 2 times 1 times 2 squared. No? So its answer is 8. Clear? Again listen. I think this is clear. Sine squared 2 sine x, x squared. Here also a squared term. Here also we have a squared term. So I wrote whole thing squared. Then you try to form sine 2 sine x over 2 sine x. Sine 2 sine x over 2 sine x. Now I put a 2 sine x here. I want to remove the 2 sine x by multiplying by like this. Clear? So no any errors now. Still, when you cut out this, when you cancel out these things, you will do the same previous step. That's it. Clear? Now this will form separately this theorem thing. I mean sine x over x and x tends to 0 thing. And this one also we can form the same thing. Clear? So just target your answer and Raisa also can understand this method. You take time and then slowly write down the things. Then if you have doubt, ask. Maria means, is it Hana, Hamid? Is it Hana or a new student? Okay. Yeah. I will read your question. Okay. Okay. You understood it now, no? Right. Okay, darling. If you have any doubt, ask Uday. Right. So this is a little different question. but very nice one. Okay. So these blue color ones are the extra terms that we added here. 2 sin x, 2 sin x here. This is some extra term. So to remove that extra term, I add another 2 sin x to this point. And this one forms this. This separately forms this. Clear? So it's sine 2 sin x over 2 sin x and 2 sin x tends to 0. This happens because when x get closer to 0, sin x get closer to 0 as well. Because sin 0 is the sin 0 can 0 to can you understand? When x get closer to 0, sin x also get closer to 0. So 2 sin x definitely get closer to 0. That's why. So we get this format. You should definitely get the formats. Show the format and then write the answers. Cos 4 sin x. Ravin, is this the part that you need to know? How I got cos 4 sin x as 1 minus 2 sin squared 2 sin x? Is it the problem? So if it is cos 4x, how to do? If it is cos 4x, what will be your answer? Cos 4x what will be your answer? 1 minus 2 sin squared 2x. Now what is going to cos 4 theta here? Cos 4 theta. Right? So how you're going to write? 1 minus 2 sin squared 2 theta. So instead of theta, now you have this sin x. Clear? So if the apply the half angle ka just write it as half angles. That's all. Right. Now 22. Tut. So that is 1 minus cos squared 2 sin x over x squared. 1 minus cos squared 2 sin x over x squared. Right? Limits of 1 minus cos squared 2 sin x over x squared when x tends to 0. Yes, when x tends to 0. Right. Now look at the board. Okay, Lamai, look at this. See? 1 minus cos squared 2 sin x. How can we write? Sin squared x plus cos squared x. You know, 1 minus cos squared x. Sin squared x. 1 minus cos squared x. Sin squared x plus cos squared x equals to 1. 1 minus cos squared x. Sin squared x. 1 minus sin squared x. Cos squared x. I use that. See? Limits of 1 minus cos squared 2 sin x I can write as sin squared 2 sine x. Is it clear? 1 minus cos squared x means what? Sine squared x, same as that. 1 minus cos squared 2 sine x means sine squared 2 sine x over x squared when x tends to 0. Okay, this is also something squared, this is also squared, so I can write this as the whole thing squared, right? So we will write this way: limits of sine 2 sine x over x when x tends to 0. Clear? Right. So then, now what can we do? Now what can we do now? See, sine 2 sine x, you should feel like sine 2 sine x over 2 sine x when 2 sine x tends to 0, because you always try to form this thing. Clear? So I will write like this. See, limits of sine 2 sine x, okay, over something new I'm going to add to the question, add to the step, 2 sine x. I added something new, so I remove that new thing, 2 sine x, otherwise it's wrong. Clear? Put them that they cancel out, over x when x tends to 0. Okay, right? So this is similar to the previous question now, right? So we have here limits of sine 2 sine x over 2 sine x. X tends to 0 means what, Pute? 2 sine x also tends to 0. Clear? Times 2 into limits of sine x over x when x tends to 0. So this is the limits of this whole product. I separate the product. And here we have a constant, I took it out. Clear? So this is also equal to 1. This is also equal to 1. Okay, so 1 times 2 squared, that is equal to 4. Right, so that is the way to do that question. You can try out this question number 23-24 at home. 23-24 mark as homework to do at do in the paper class next week. Right, I had to, we have some 5 or 6, like maybe 7 or like 7 questions to do, right? We will do that next week, right? Because the other format is also there, that x to the power n minus a to the power n over x minus a when x tends to a. That format is also there in those questions. So I will explain that next day and we can practice more questions from that. You all 23 and 24 for homework. Okay, that one we will discuss next week. Similar questions. 23, 24. You do 23, 24, 25, 26 all. Yeah, 23, 24, 25, 26 all for homework. Clear? Other questions we will do with me next week with a new paper, right? Before doing that, I will just discuss these questions and finish this work, right? Raise hands those who can understand this very well. Then we to how to make the formats and those things. Can you understand? Right, you go through these questions again, right? Go through these questions again, right? I hope that this was a very good advantage for you. We tried different questions, and also ළමයින්ට ගොඩාක් වෙලාවට මෙතන තේරෙන්නේ නැති තැන තමයි ඔය අර formats හදාගන්න එක. I think that now you can understand this. We did so many, right? I think you can understand this. Okay, so you all do the 4 questions I told you for homework. Okay, right, goodbye ළමයි. Good night.